Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at finding a trigonometric equation. So you'll either be given a graph or information about a graph, and you'll turn this into a trigonometric equation, so an equation involving sine or cos. So let's look at this graph here, and we will find the equation of this graph. So it's either going to be sine or cos, so it's going to be one of these. So just as we did when finding the equation of a line or a parabola or even a hyperbola, all we need to do is find the value of these three coefficients. This just had the added step. We need to first determine whether it's a sine or a cosine graph. So to determine whether it is a sine or cosine graph, we use this rule here. We know when x equals 0, sine graphs start at their mean position. They go up to their maximum and then down, whereas cos graphs, they start at the maximum, they go down, come up, go down, come up. This graph here starts at the mean position. The y-intercept is the mean position, halfway between the maximum and the minimum. So this graph here in yellow will be a sine graph. So it's going to be a graph of this form here. So now we just need to know what A, B, and C are. So we're just doing the opposite of when we were given an equation and turned it into a graph. So remember, this number in front of the sine or cos is the amplitude. So whatever the amplitude is, we just write that in front. B can be found from figuring out the period, which is really easy to do. And C, this value by itself, is the mean position. So for this graph here, A and C are very easy to work out. In this graph here, A, the amplitude, is the distance from the mean position to the maximum, or the mean position to the minimum. So from the mean position, the distance here is 5 up. We also go from the mean position 5 down to the minimum. So here, A is 5. Remember, it's not the distance between the minimum and maximum. It is actually half that distance. So we wouldn't go 6 minus 4. If we wanted to find A that way, we need to go 6 minus 4 divided by 2. It is half the distance between the minimum and the maximum, so A is equal to 5. Now C, the mean position, well, that's really easy to see here. It's halfway between the maximum and the minimum. The mean position here is 1, so C is equal to 1. In other words, this sine graph has been shifted up 1 to get the mean position. Okay, the final thing we need to find is the period. So that just takes a little bit more work, but it's not too difficult. Now we can see that the period of the graph in yellow, very easy, it's the distance between the two peaks. So the distance here between these two peaks is 12. Similarly, the distance between the two troughs, the two minima, 9 to 21 is 12. So the period is 12. But I'm not saying that B equals the period. The period is just how we find B. The period's 12. Remember that when we're doing a graph, the period is 2 pi divided by B. That's if we're in radians, or 360 divided by B if we're in degrees. So you need to know whether the question is asking you to give the equation with x in degrees or radians. So let's say in this case that the question's asking for radians. So we'd use that. So we know the period is 2 pi over b. The period is also equal to 12. So what we have, 2 pi over b equals 12. We need to solve that equation. So the quick way is just to move the 2 pi and the fraction line over. So you get b is 2 pi over 12. This is the same answer we would have gotten if we times each side by b and then divided by 12. So make sure you can solve that equation. So of course 2 pi over 12 simplifies to pi on 6. So we've now calculated A, B, and C, and we also knew that this was a sine graph. So now we can write the equation very simply. The equation would be y equals A sine B, I just figured out, was pi on 6. A sine bx plus c. Then we're done. So now we're going to look at a worded problem in which we calculate the resulting equation. So let's look at this question here. The distance that the tide reaches up a coastline follows a trigonometric equation. On average, the tide reaches 5 meters up the coastline at 4 a.m., which is high tide, which occurs 12 hours before low tide. The tide reaches 9 meters up the coastline. So we're going to let y equal the distance in meters that the tide reaches up the coastline, and x the number of hours after 12 a.m. We will find the equation linking x and y. So when we're given words like this and we have to find the equation, you don't have to turn this into a graph, but I'm going to do it here just to show you what's going on. So let's start by labeling our axes. So we'll start with the x-axis. So x is the number of hours after 12 a.m. So we're told that high tide, the maximum, occurs at 4 a.m. This is 4 hours after 12 a.m. So the high tide is going to occur at 4. Now, because we said the high tide occurs 12 hours before the low tide will occur over here at 16. So 16 means 16 hours after 12 a.m. This is 4 p.m. So high tide at 4 a.m., low tide at 4 p.m. So looking at the y-axis, well, we were told that the maximum the tide reaches is 9 meters and the mean position is 5. That's what it means by on average, the tide reaches 5 meters up the coastline. So, of course, by what we know about trigonometric graphs, that means the minimum must be 1. The distance from the mean position to the maximum is the same as from the mean position to the minimum. So we can plot a few points here. So at 4 a.m., the maximum tide occurs at 9 meters. At 16, we know the minimum tide is going to occur. So that, of course, means that halfway between them, x equals 10, it will hit the mean position of 5. Now, we know that if the distance between the maximum and the minimum is 12, it will be another 12 until the next maximum. So the next maximum will occur 12 later at 28. So it will occur up here. Sorry for my poor drawing. And that will help us calculate the period. So trigonometric equations are great for things like tides because this is exactly how tides work. So they'll reach their maximum, they'll come down, they'll reach minimum, low tide, and then they'll go back up, reach a maximum, and they'll do the same day after day. They keep coming down, up, just like a trigonometric equation. So essentially what we want to do is find an equation that fits this graph here. So this one's a bit tricky. The reason it's a bit tricky is because of what I said on the previous slide about determining whether it's a sine graph or a cosine graph. Now this graph here does not start at its peak. But the problem is it also won't start at the mean position. So if the mean position's here at 10, it'll be over here again at x is minus 2 because the distance between those two will have to be 12, half the period, right? So it doesn't start at its mean position and it doesn't start at its peak. We actually don't know where it's going to start. So we can't tell whether or not it's going to be a sine graph or a cosine graph. What we can do in this situation, however, is we can take a cosine graph, which should start at its peak, and shift it across 4 units. So that's what I'm going to do here. We're going to start with a cosine graph and shift it. So rather than starting at its peak, it's going to start over here at 4. So this time we're looking at a cos graph that has been shifted, and that's why I've added in this extra box. Now calculating A, B, and C, that'll be exactly like we did on the previous slide. So A, the amplitude, remember there's a few ways to think of it. It is the distance from mean position to maximum. It's the distance from the mean position to the minimum, or if you like, half the distance between the minimum and the maximum. So either way, you should get A equals 4. So now let's look at C, because that's easy to calculate. C is just the mean position, so in this case it would be 5. So now what we figured out before, the distance between the two maxima is 24. That means that the period of this graph is 24. So remember, that doesn't mean that B is 24. So let's assume that this is again in radians. So because the period is 24, that means 2 pi over B is equal to 24. So remember, we can find B easily by just shifting the 2 pi and the fraction sign. So B will just be 2 pi over 24 or pi over 12. So we found A, B, and C, but we just need to do something additional in this equation to shift it over by 4. But that's actually really easy by what we know about transformations of graphs. So remember, if I want to shift a graph left or right, I just replace x by x plus something. I'll call it k. Remember though, this goes in the opposite way that you'd expect. So if k is positive, it goes to the left, and k is negative, it goes to the right. So because I want to shift this graph 4 to the right, I want to replace x with x minus 4. So what I'm going to do in my equation here is replace x with x minus 4 and put another bracket around it. That will shift the graph 4 units to the right. So then I have my final equation. All I need to do is sub in A, B, C, and all that. So it will be y equals A cos, so B was pi over 12. Now I times that whole thing by x minus 4, because all I'm doing is replacing the x with x minus 4. So then I add C on the outside. So I've got y equals A cos B x minus 4, to shift it right 4, plus C. And then I'm done. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.